Hello and welcome back. We are here in San Francisco, California for the Build 2016 edition. My name is Seth Juarez. This is Channel 9 Live, and we have a special treat for developers that are watching today. I have always loved the promise of HoloLens, but I've never gotten to speak to developers that made something for HoloLens, so I'm pretty excited to talk to you about sort of what you've been working on. So why don't we start first by introducing each one of you and what you do, and then maybe we'll talk about the project that you worked on and what aspect you work on, and then we'll get into the nitty-gritty some code. So let's start first by introductions.
Cool. So I'm BJ Malakut. I'm a developer on the team. We worked on Galaxy Explorer. So some of the things I did was working on the scene management and view loading aspects, also input, toolbar, stuff like that. So I think we can drill into it more when you're ready. But
let's do it.
My name is Mike Felice. I'm also a HoloLens developer. I worked on transitions, points of interest, a bit of view loading, things like that.
Okay.
My name is Karim. I've been working as a dev on Galaxy Explorer, basically doing everything graphics and performance.
Awesome. So the Galaxy Explorer, what is it? High overview. So let's go above the developer level and let's just talk about if I was to download or use Galaxy Explorer, what would I be experiencing? What is it? So we'll start here and we'll get all your take on it.
Sure. So when you boot it up, what you'll be greeted with is basically you place Earth, and then from that you kind of go out to our solar system and then the galaxy to show you, our scale, where we fit into the picture. And then from there you're free to explore as you see fit. So you can see NASA imagery of nearby nebula in a cool little magic window that we built. And then you can travel back, air tab and travel back to our solar system, visit all the planets you know and love, including Pluto we put in there. And you get...
But it's not a planet, man.
I know. We actually had a community vote and we were like, should we add it or not? And they said yes. So,
nice.
And then also, whenever you visit a planet or destination, you get voiceover telling you cool facts and stuff like that. Stuff like I didn't even know. So when I'm using the app, I'm learning new things. So it's pretty fun.
That's awesome. So I could live my childhood dream of being a spaceship captain.
Yes.
I'm pretty excited. Go ahead.
This is started from the community. So basically we asked, what does the community want to see in an app on HoloLens? We had more than 5,000 ideas. And from there we trimmed it down, and then we had a vote with the final 3, and that's how we came to Galaxy Explorer. And it was largely like, what do you do? Solar system, how do you view that? Where do you take it? And we played around with a lot of ideas, and that's how we came with the app that we ended up with.
So you put out a APB on all developers, and Sue Dev, she said, I want you to explore the galaxy. And there was a lot of people, a lot of submissions, and they voted on that eventually.
Yes, that's right.
Were there any other interesting ones that devs can go out there and look at your stuff and build that too?
And other interesting
entries that you knew of?
Actually, I thought all the entries were super interesting. Really, they were. And Galaxy Explorer wasn't my first pick, just because I come from a gaming background. I was like, oh yeah, grab the idol. But
Nice.
going through the solar system, I'm super glad that the community picked that. It's been a great experience. I've learned a lot about everything, and it's just been fun.
Yeah. Kareem.
And so the way I feel it is that we had to explore the universe, we had to explore the solar system and visit each planet. So we actually spent a lot of time to look around at pictures, look around at stars, what are planets, what we can get, and how we can actually make it happen. And I will always remember that first time when we put the Earth inside of a room and we were looking around, and it was like, wow, we are looking at the planet and we can actually go around and see everything, see the clouds. That was magical.
All right, so we have some footage. We have some footage of the stuff that you worked on, so we're gonna put it on the screen. So we'll start with the stuff that you worked on, BJ.
Sure.
So let's get that queued up, Mrs. Producer. And okay, so you can see right over there, that is a literal galaxy that you built.
Yeah, so Kareem will talk more about how we rendered that, but he and some of the technical artists looked at a ton of research material to get that, so I won't spoil that. But what we're looking at here are the toolbars and interactions. So our main goal there was we want to focus on the content, let you see everything because we spent so much work making it look beautiful and amazing, but we also need ways for you to discover what you can do with it, how you can interact with it. So we built this toolbar you can see there. We have grab to reposition it in your space. So if you want to sit down, kick it on the coffee table, you can drop it there. And then you can zoom in by clicking and dragging left and right to make it bigger or smaller, so that's what's going on there. And then you can also tilt it, so if you want a different view, we sort of gave what we called hero views to each of them, where it's it looks good from this angle, but maybe you want to tilt it and look under it or something like that. And then what you just saw was reset, so it gets you back to a known good state, it looks at you, it's full size, stuff like that. And then we threw in an about window because we have to do attribution and stuff like that. And then the last button's kind of interesting. It helped us solve the problem of like the content and the tools. Like I said, we want them discoverable, but not obscuring content. So that will actually drop them down so they sort of get out of your way. And then you can use voice commands for all of them too. So when you look at them, it'll show what you can say to use it. So once you're good at it, you can drop them out of the way and then just use your voice.
Now this is really interesting because I think it's lost on me as a dev. I'm used to working on my my app that I touch or that I have, and even the newer interfaces where you talk to. But now, effectively, we have to be able to control a computer somehow with no keyboard, no mouse, no touch. I mean, it's kind of touch. How did you come up with okay, this is the form factor that we need to use, or this is where I should put these things? What are some considerations for this type of NUI that we need to take into account as developers that you found building Galaxy Explorer?
Sure. So the big thing, we have gaze, gesture, voice, and then also clicker, if you've seen that, it comes in the box. The gesture and clicker are sort of similar. You can do basically the same thing for it. When you click it, it's like an air tap, and also you can move it up and down and left to right, just like we did the emotions. But we try to use like complementary things. So if it's something that you're going to say a lot, like we want to say tilt up, tilt up, tilt up as a voice command because that'd be obnoxious. So you just say tilt to activate it, and then you have nuance control with this. So you really want to do complementary. You have all these interaction types you can do, and you just want to make sure you're using complementary style with them.
I see. So it's less of a, we're just going to use our finger for this,
right,
or I'm just going to say this thing. It's actually sort of a combination of the two. How do you even start to engineer? So 2 questions to get them out of the way. The first one is, what are the available gestures so that, and text commands? And the second one is, how do you start to engineer that experience with composite sort of actions to do something meaningful? We'll start with that.
So for the first one, gestures, we use the simple ones. We built this thing in 6 weeks, so we couldn't really dive deep into gestures, but we just use simple ones. So air tap to select something, and then tap and drag to tilt or zoom up. And so basically we start with that and we say, I don't know if you could tell in the video, but you have a cursor and that shows where you're looking. So whatever you're looking at is what your interaction goes to. So if you're looking at a planet and you air tap, you'll go there. So you always have a cursor on screen letting you know sort of what you're going to interact with. So it doesn't matter where you're tapping. It's just that you tapped.
I see. And so it's the combination of the gaze,
Yep,
because there's a little dot of where you're looking at, and then this thing plus what you say.
Yep, and so for your second question, we do a lot of prototypes. So early on, like the first week, we spent prototyping. So we would do different interactions to say, like, does this feel right? Or should we use voice here or gesture here or what? So we do a lot of that, and then we like do it in the team and figure out what feels good. And then we have people outside the team that come try it too, and they give us feedback. And through all that, we sort of distill down what we want to do.
I think what's getting lost on me, people, is that this was built in 6 weeks.
It's important.
I couldn't do my taxes in 6 weeks, people. And you're exploring the galaxy in 6. Thank you for that, making me feel like I don't know what I'm doing. So we'll move on to you. Tell us a little bit about what you worked on. I think we have some beautiful footage of that. So let's get that queued up. Tell us what you worked on, and then we'll get that queued up to go.
So the transitions are one of the big pieces that I worked on. We actually have, this should be it. So basically what BJ described, how you interact with things, we're gazing at a destination marker and we're air tapping to get into a different view. So we start with galaxy, we move on with solar system, and then from there we move on to a planet view, and you can move between them basically using speech, gestures, everything that BJ talked about. The transition part, in order to get everything to go smoothly, we don't know where the planets are going to be in the orbit, so it's all programmatic. Unity was actually really helpful. This is what we developed in both in the 6-week project, getting something up very quickly, and then also with the transitions, because you can play around with the hierarchy and move like a single object around to get the final positions and sizing that you want. And so I played around with that just to get it in the view. BJ also mentioned the hero views. That was our goal. So when you see us go to a planet, the sunlight is always coming from the same direction. It's about a 3/4 lit planet. And it's always going to do that, and so we want it to look good.
That's really interesting because it brings you said Unity kind of really fast, and it kind of just slipped out, right? Because now Unity is traditionally for game development, is it not? And so tell me how Unity fits in with building applications for HoloLens. Why is it an important thing?
For us specifically, getting something up and running very, very quickly, Unity has been phenomenal. You can prototype things very quickly. The prototyping stuff that we did in the beginning to figure out what kind of input types we wanted was invaluable. I don't think we would have been able to complete as much as we did without something that was able to get us running very, very quickly.
So that's an interesting, also an interesting observation. Like when I'm used to writing, like when I did games a long time ago, we would set up the scene and then the thing would render at whatever frames per second, your machine would let, and then you'd have this sort of world. But the difference with games is that this world only exists in the screen. But now what you're trying to do is you're trying to superimpose that game onto reality. What challenges did you face with that?
There are several challenges because in Unity you have an editor view that you can see what the scene looks like. However, it's not truly representative of what you'll see when you wear a HoloLens. One camera instead of two cameras. Also, everything feels differently. When you can see something in your space versus on a screen, it's completely different. And that's just part of the iteration process. And mentioning Unity again, being able to iterate quickly lets us adapt to this doesn't feel the same way it does on the screen, so let's change it. It allows us to do those kinds of things, and we develop tools around that so that we can iterate on device for fine-tuning.
That's awesome. And so essentially, you're building these worlds on the flat screen, but then you have to test them to see if they're not wonky when you're looking at them, because now it's actually 3D-esque that you're doing that. What were some of the challenges that you had going from that to the other?
Definitely it's the size of things, right, and how it fits in your space. We played around a lot with this. We actually at one point had something that was a fit to your room view, and because it's like, oh, if it's blow it up, make it super big, how does that feel? And we iterated throughout the whole project. And the pieces that we like, you'll see in the transitions when you go from like galaxy to solar system. The galaxy gets really large through that transition. It feels like it goes right past your head. Mm-hmm. You get the audio, spatial audio with that too, so it's like a whoosh sound.
That's really cool.
And it's a really good feel. And we moved away from making the content super large in your room without your control, which is where you get the zoom, so you can fine-tune the control. If you want it large, you can make it large. If you want it small, you can make it smaller. And that was just part of the iteration. Something that you can't really do as easily on an editor or on your screen, on your computer, no. but on HoloLens, when you're playing with it, you're actually realizing, you know what? I feel a little bit bombarded at this moment,
right?
But I like this feeling, and then you can play around with that. It's really neat because some things feel better than other things, and you just play around with it.
I suspect there were moments where you're like, "That's coming at me too fast. It's my primal nature is shooting off, and I need to duck, and this is weird. I'm going to break the HoloLens, and someone's going to get mad." Was there moments like that where you realized we need to tone it back just a hair?
There are definitely moments where you amp it up too fast, and that's part of the fine-tuning. So one of my goals when I was developing the transitions was to give a tool set to our animator who can fine-tune all of that. Okay. So the more that I could give him to control those from my perspective, but when you actually get an animator in there, it's going to look better from everyone's perspective.
Of course. So were any of you in the part of the animation, like the artistic part? Or was it just all you did the dev and you handed it off to some? I don't know.
We collaborated for everything. Absolutely everything was collaboration. It was really nice being in a room where all the disciplines were in one room. It got us talking. So the transition pieces that I built started off as a collaboration. When we were prototyping it, there were things that really called out, you know what, this feels good, this is awesome. And that's why we decided to make a programmatic solution.
Awesome.
Because we knew that we could fine tune this and get this to a place where it feels good and our animator feels solid, like this is great.
For those that are joining us from the keynote, we are here live with developers of Galaxy Explorer, which is a community-driven sort of prototypical HoloLens type application that maybe one would build, and you put this out to the community so they could see how to build these kinds of applications.
Yep.
Right, and so we're going to go to Kareem, who's going to tell us just give us another overview of what Galaxy Explorer is for those that are tuning in right now.
Sure. Galaxy Explorer is an experience when you can actually go and explore the whole solar system in your living room. You can explore the galaxy in your living room, and basically we give you the opportunity of putting planets on the star and the whole galaxy wherever you want.
It's pretty amazing. And if you are watching, please send some questions in. I have spent a lot of time with the people that market HoloLens and that talk about HoloLens. but I've always wanted to sit down with the actual programmers of the thing. So if you have questions for how to actually develop stuff for HoloLens, these are your peeps right now. Please send in your questions. All right, Kareem. So let's get into a depth a little bit more about what you worked on. I think we have some footage. We didn't show your footage yet. Let's show some footage of what Kareem was working on. It's on the screen right now. Why don't you describe what's going on and what you did here?
So I basically worked on making things beautiful with the help of our incredible artists. And so you are looking at the galaxy, and the way we wanted it is we wanted the galaxy to feel like a cloud, filled with stars. And we did a lot of iteration on that to actually get that feeling right. And so this is why right now you can see that there is the whole cloud layer of the galaxy on the stars inside of that. And we had to come up with a system that would allow us to render that as a whole particle system. And the way we did it was to have a few tens of thousands quads that represent each piece of cloud that we render on the screen, and that gives the cloud layer, and then have the same quads with a star texture that will give you this little sparkle in the galaxy. And because we are working with artists and wanted to actually get their inputs and their feedback on how it looked, on how it was, even the shape of it, I actually worked really closely with a technical artist and a 3D artist to give them all the control they wanted to shape the galaxy however they wanted, and yet have it running at a good frame rate on our device.
So that's awesome. So you kept mentioning some designers, all of you did. Can you give us a sense as to how you structured the team and how you divided the work if someone wants to build? So here, let's start with this. Do I have to have a cadre or team of designers available at a moment's notice to help me with these kinds of things, or can you just build something for HoloLens? We'll start that first, and then we'll talk about your team structure, because obviously you were compressed, and so you needed some extra help. So let's start with that. Can you just make something for HoloLens if you wanted to?
Yeah, so it's super easy. What we did, since we already had an existing team, was we took a subset of that team. So we had production, animation, like Mike mentioned. We had design, we had like creative, we had concept artists even. We had all these people. Sorry if I left anyone out. But we had all these people, and it was a really solid team. And that allowed us to get to the high level of polish you see in the video. But you definitely don't need it. Like, we've done individual things at work where it's just like, okay, we have a spare week, so go work on something as a dev, and you can make some pretty amazing things.
A spare week?
Well, yeah. Like
you mean a dev week, right?
Yeah.
Because then you got to add in that time where you sit around, and you look at videos. You got
to cat videos, everything.
Sure.
Yeah. But even in that time, we're able to make really compelling things that maybe they're a little rougher on the edges in terms of like you need an artist to come in and clean things up, but they show off an idea, something that's actually compelling that hasn't been done before. So it's pretty easy to get going, especially with Unity.
So let's get into sort of the other aspect, which is interesting to me. Because, I mean, when we're looking at this stuff on screen, there's a beautiful black background, and everything looks really nice. But when you're looking at it through HoloLens, you're sitting in your room, it might be really bright, there might be stuff all around. How do you sort of fix that? Because there's an element of control that you have when you're building games that does not exist when you're building HoloLens. How do you sort of work with that?
So there are multiple ways that you can fit things in your room, in the space, and actually collide with the meshes of walls and floor and ceiling and things like that. We actually started with a bunch of prototypes, and we're like, you know what? This isn't as compelling as some of the other things that we can do, and given the amount of time we have, let's make the right choices. But some of the things that we were doing were figure out the boundary of your room, going to full screen with the content. Also, we had somebody who we'd done this before, and so we thought it would be a good sell for Galaxy Explorer, where you could use glow and reflect light off of surfaces. So like you could put the sun on your coffee table, and you would see the glow of the sun reflecting off of the surface, which is really cool. In Galaxy Explorer, when you look in the Galaxy, there are portals you can look into that have a 2D card, and you can get the parallax as you move around to further inspect what it is that you're trying to view. And we've done that also through walls. So like you could have a window, and outside of your window you could see something completely different, run a movie, it's basically anything you want to do. And we've done really interesting things like that in the past, and those are the kinds of things that you can do to interact with your environment. Basically, the way that you interact with it is you get meshes. So you get the callbacks with the meshes, and you can do anything you want with that you could normally do with a mesh.
That's interesting. And so what you're doing is, and this is interesting to me because when you were talking about the toolbar, there was sort of a composite sort of set of actions to make something happen. And now you're saying with the real world, there's a composite set of things that you can do to integrate. Because the goal is not to like overimpose, but to superimpose on top.
That's right.
What were the biggest challenges you found with superimposing things, other than, you know, what do we do when there's stuff in the way? How did you come up with ideas like the one you mentioned? Go ahead, Kareem.
I think one thing that we discovered is whenever you have a space simulation, you expect it to be in a dark spot, and you can play with that to actually achieve the light on the style of color you want to have, which doesn't really work when you actually have a kitchen or have a living room or some kind of different environments. So we had to tune a lot our color and how everything was looked, and have them not be too bright but not be too dark, so that they would actually show up in a good way, disregarding any light that was coming already from the environment. So this required a lot of tuning from our artists to actually make it look right in terms of light conditions.
So as a dev, you know, like you run it on your box and it works, and then you go and run it on some other box. Now you have the additional thing with HoloLens is you're running it in your office, and then you go somewhere else and you're like, oh, man, we got to tune for that. Was there location problems, like if you were at one location versus another, that sort of revealed some tuning issues?
Not really, actually. In this one, we were pretty lucky because one of the first steps that we have you do is like pin the Earth to the spot you want it to live. So actually, last night we took it to a place to show off to some developers, and we were a little concerned that maybe it wouldn't work because we hadn't tested in that environment, but it worked fine because you decide where you want it, and if it's, like if you put it in a corner, you'll have a worse experience because you can't get around it,
Sure.
But if you put it in the middle of the room or above the coffee table, it's great. It's just going to live there, and if you need to move it, you can just grab it and move it somewhere else. So this one was sort of simple, so it worked out pretty well for us.
Awesome. All right, so we have some questions. We're going to take those now, but please remember to have your questions come in. We have real, actual HoloLens developers that will answer real, actual HoloLens development questions. I'm pretty excited. The first question from Hank, we know we can't see black holograms, but what happens when you get close to black? Like a navy blue or dark green, does it start to look weird? Like a black hologram, what do you do with that?
This is actually one of my favorite things because we have some like black elements that you'll see.
Space.
Yeah. But even in the shell, there's like tiles that are black. But what we do is we use like really cool highlighting effects to actually put borders around it and stuff like that. And honestly, your brain is convinced that there's a black thing there. Like you don't see whatever's behind it. So like we do it countless times where you feel like there's black there. I know it can't technically do black, but I can see this is a black tile just because of the way we do highlight effects and stuff like that.
So you are literally tricking the brain by putting an outline there.
Yep.
And then like putting white text or something,
Yeah,
and then
just
it
a
looks
glow.
like it's a...
Yep.
We also had this thing for planets because if you actually look at space picture of Saturn, you see that there's a very sharp cut between everywhere which is light, and then there's just nothing because there's just no light at the back of the planet. And that looked weird, so that's why we have a little ambient light at the back to actually make you see that, yeah, this is a planet, I can see the back face, and I can see the front face, and it looks correct.
And does our brain sort of just fill in where the gaps should be? I mean, I'm trying to understand.
Yeah, like in that case, Kareem's describing, it's such a smooth fall off, like it totally makes sense to your brain, so yeah.
That's crazy.
So download the code, check it out, you'll trust me when you see it.
Okay. Next question, what programming languages do you guys use to build these awesome animations? And I think we need to be clear, they're not just animations, it's a holographic program, right? So what programming language? Let's get into that.
We use C#. So basically we use Unity to set up a bunch of our objects and our scenes, and how we want to go from scene to scene and manipulate the objects is done in C#. You can definitely program in C++ if you wanted to. Create your own DLLs, build your own set of tools that you want to use. That works well too.
Awesome. Next question, how could I take a 3D UWP game built in Unity for screens and take it to the 3D space of HoloLens? That's a really good question.
Yeah.
You already have an existing game. We want to move it to HoloLens. There's obviously some things that you need to think about this, this, and this. What would those thises be?
I can list some of them, you guys can help out too. The biggest one for me is like, when you're working in Unity normally, you think like, oh, I'll just use whatever units make sense and whatever gravity units make sense, stuff like that, just to make it feel good in the game. But when you're actually doing Unity for HoloLens, 1 meter is 1 real meter. So you sort of have to like reevaluate the system of units you were using and then make it make sense there. And the other big thing is like, sort of with the toolbar, you can pin something over here and then it's over there. So you need some way to like get it back to the user user, or at least like a noise or some indicator that something's over there. So with like HUD style things, you just need an extra indicator of like, hey, maybe you left something over there and it's in the other room, you know? So it's sort of those type of things that indicate where things are. Like we use audio cues a lot, or visual like arrows to do that. So.
That's interesting because in a game, right, you just spin your dude around like a 360, but in real life, you have this thing on. You might have left something over there that's not technically real, but it's still important to what you're doing.
Yeah, exactly.
Excellent. Any other considerations?
Definitely camera controls. So you are no longer controlling input through a keyboard or a mouse or a controller. Instead, you are the camera. What you see and what you are doing is through your view. Taking that into consideration, that may, depending on whatever the app is, require some redesign. Just because you're going to be physically moving in your space more to get the views that you were getting before just with input through a controller. And similarly, like with input, there are so many different ways that you can interact. And when we were going through our prototyping, we found that multiple combinations of gaze and voice or gaze and air tap really helped integrate the development, like the actual end result that we wanted, and make it seamless, like make it feel right.
That's awesome. So what about you? When you're moving from you make your game, I love that, by the way, I love that you said the camera is no longer in your control because it's the person, she is now the camera that's using it. That's a really good sort of break. Kareem?
I think from my point of view, there's a whole lot of little graphics tricks that don't really work in stereo because, for example, if you want to do a lens flare, you will do it in 2D, just adding something on top of the screen, and it will look like a lens flare. But if you actually look at stereo, it will look flat. So you have to come up with different kind of tricks to be able to achieve your effects. And stop thinking that it's just a 2D screen, but really thinking that, no, I have two eyes looking at something, therefore everything flat will look flat and not actually
That's really
like
cool because usually when we say stereo, we're thinking audio, but you actually use that term to represent visual problems, which is because now we're saying now visual is actually in stereo as well because there's two things that we're looking through that help sort of the 3D. All right, let's go to the next question. All right, does the Galaxy Explorer use any 3D sound? You mentioned this briefly, but let's get into this a little bit more tighter.
Yeah, so we have a great audio engineer who put in 3D sounds everywhere. So it's pretty cool. If you go to like Jupiter or something like that, there's a huge storm raging there, and you can actually hear the winds of the storm whipping around. And if you have Jupiter here and you turn this way, you're going to hear it out of this ear and not so much out of this ear. So it sort of lets you know it's over here. So we use it all the time. If you go to Earth, there's another good example. We have the moon orbiting around Earth, and we sort of have like a little satellite noise too, so you can kind of follow that around. Just even with your eyes closed, you know where it is because you can hear it going around your space.
Well, now I'm all kind of want to play with it, guys. I mean,
we can let you play with it.
Nice. They're going to let me. And by the way, I think it's important to note that if you do have the developer kit and it has been shipped to you, the code that you wrote is all open source, right?
Yeah. So
where is it?
So it's on GitHub. We can include a link, but what's awesome is you don't even need a device. We have an emulator you can use. You can also just play it in Unity itself. So most of the time we do development, we just run it in Unity and then we check it on device and stuff like that. So you can do almost all our workflow that we do, and then when you get your device, you can finalize whatever changes you're making. So it's pretty exciting.
I think what's cool is we're not just sort of dumping this thing out and saying, hey, good luck, now you just don't have the audio problem that audio is wherever your face is, right? Mm-hmm. Now you just don't have the stereo vision problem, and you don't have like this new holographic area, and we're just going to say, hey, good luck. We're actually giving you something.
Yeah.
All right, next question. How did you debug the app? Have you created a desktop version first, or did every developer have a HoloLens?
There's a combinations of things. We can do a lot of debugging in Unity just to verify that your code is working, no crashes, things like that.
Yeah.
And then you can basically take your app and put it on an emulator, which is what DJ said if you don't have a HoloLens right there, or you can put it on HoloLens. We were testing directly on devices. You can actually use Visual Studio, which is what we used, to debug the application directly on device. It actually really helped for deployment as well, because you're just like, go. And it would start up the app, and then you could play around with it, and you can see what values are actually running. So if you want to tune things, you could potentially, it's like you have access to everything right there, right? So it's very similar to working on other platforms where you can debug remotely.
So let's get into the sort of developer loop, and then we want more questions. So please get your questions coming. But I had a question. What was the development loop like? Like when I'm running a regular program and I hit F5, right, and then I get to the breakpoint, I look what's in there, and then I see what's rendered to the screen. If you're doing game development nowadays, you can debug by pixel and see how these things are getting rendered. Was it Was it similar? I mean, when you hit F5, are you pushing it to the HoloLens? Are you pushing it to the screen? Is the loop a little bit different? Can you talk to that?
It's pretty much the same loop that you would get for other platforms as far as deployment and debugging remotely. And then also for just process, we had a lot of iteration cross-discipline, and so we would do a lot of work in Unity, and then you could see in the editor, okay, does this look right or look like something we want to push to the device to actually verify that it does what we want. So that was pretty much the flow that we had for that.
So it's just box and then device, or was it always you're on VS and you go directly to device?
It's pretty much box to devices with the way that I've been doing it. There's no set rule for how you need to develop it, so whatever works best for you. But I was programming in Visual Studio, and then I would verify in Unity, so it was a lot of jumping around between Visual Studio and Unity, and then from there I would build my app from Unity, and then I could deploy it. So it creates a solution, and then from there, that solution in Visual Studio, I can deploy it, and yeah, exactly.
So you need more screens, right? I'm asking the boss for more screens, man.
You mentioned the frame debugging sort of thing. That's something Kareem did a ton of, like determining draw calls and stuff like that for optimizing. So
why don't you tell us about that? Because there was a video I did at GDC probably a year ago where we introduced this. You can get to the pixel and see like where, like all the way down, like what was getting. Were you using that as well?
So the good news is you can still do that with HoloLens.
Nice.
The 3D graphics diagnostics is just awesome, and you can use that to debug your draw calls, how many are there, how long they take, what is your pixel doing, what happened on your pixel. This is just incredible, and yes, I've been using that a lot.
But is there two pictures though? Because there's two things in front of you. Is it two pictures, one picture? I don't understand.
So there will be two phases, because you will render everything on the left eye, everything on the right eye, and you can see like both pictures
I
are
see.
there.
And so if there's ever like an aberration, you have to see, is it left eye or right eye, or is it both, and then that changes the way you debug, or how does that work?
Well, it really depends on what kind of things you are trying to do. Usually there was no problem for actual 3D object, but for the galaxy I had some fun moments where I would see the galaxy only on the left eye, but not on the right eye, and that feels really weird.
And you stayed up really late that night trying to fix that stuff, right? All right, next question. Miko says, in my country it's dark and dull and rainy. Thank you. Can HoloLens Beat answer to bring me bright sunny beach into my cubicle?
yeah, we live in Seattle, so I think we're from the same country. But yes, you can do whatever you want. So actually what's really cool is when you look at the sun, like we were demoing last night, and you could tell when people got to the sun, because you can actually see the glow on their face. Like I could look at you and see it glowing on your face. That's how bright the sun is. So I think it might help them a little bit. It won't be warm though. So.
Yeah, get a little space heater and then put it on, you know what I'm saying? All right, next one. What is the cool HoloLens project idea you wished you had the time to work on? This is, I know, man, he should be up here, man, I'm telling you what. If you could work on a project, let's just say you had extra spare cycles, and we devs are crazy, we'll stay up all night and do something. What would you build? We'll go for each one.
So there was a cool share your idea about piano, teaching you how to play piano. That seemed really cool.
Oh.
I don't know piano, and it seemed awesome to be like, you know, you could actually annotate like, okay, you hit this key, then this key, this is a chord or whatever, and so you could actually teach people how to play. And so that was a compelling idea to me.
Would you be able to superimpose it on top of a real piano?
Yeah, exactly, and actually have it aligned up to the key. Like that would be awesome.
Push this button and this button, not the same. That's great.
For me personally, I like interactions, and I like what basically bringing the mixed reality feel so you can interact with your room. I mentioned the grab the idol before, but that kind of falls in line. I would want something that's like more game-like, where you can interact, move around a lot. There are other applications that are out there that do that already, but that's probably what I would gravitate to.
Yeah, I would want to be Indiana Jones and the space guy at the same time. Kareem.
Actually, I had an idea similar to the piano one, which is be a DJ with HoloLens. I always dream of this thing where I have my plate and I can actually see the holograms over the sound I'm playing and be able to mix using that. I think it would be kind of awesome.
That would be awesome, because then you could control it and you could have stuff everywhere all around you. Man, good question. I know this may seem common sense, but can I use Visual Studio for HoloLens?
You can. Sure.
Would you use anything else? I mean, I don't.
I mean, you don't have to use it, but if you want to debug, you use it. So yeah, you could definitely just like build and push, but yeah, I think you have to use it. And so
when he says have to, he means like
you want to use it.
He means like you really. It's nicer. Okay.
It's amazing.
Did you classify Pluto as a planet? You mentioned that at the beginning when we weren't live. Why don't you tell everyone how you came to the decision whether it's a planet or not?
So we don't actually call it out as a planet anywhere, I don't think, but it is there. So we have all the planets you know and love, and then Pluto. So we took a community vote actually, and unanimously we wanted Pluto, so we got.
So the community believes Pluto is again a planet.
Yeah. Breaking
Blessed
news.
day. What's the scale of the galaxy we're talking about? Solar system only? If it goes beyond that, is it the planet stars was procedurally generated, or use some sort of NASA data? So what's the expanse of the galaxy for you, and how did you sort of get the right data? Did you have someone sort of giving you input along the way, like some kind of NASA scientist or something?
Yeah, so for the galaxy, it's a trick question because you cannot really know what it looks like. We can only make happy guesses using NASA data on imagery that our telescope gives us. So we kind of try to match what NASA guessed about how the galaxy is supposed to look like, and where the solar system is supposed to be in the galaxy, and where stars are supposed to be. So you will see some point of interest around the galaxy, and this is again probably happy guesses, but that's what NASA thinks where this object should be. And so we put them where NASA said that they should be.
So NASA literally helped you make the galaxy? Is that what I'm saying? So NASA and Indiana Jones and HoloLens, man.
But just to continue that subject, we also have had help from Microsoft Research. We had a scientist from there helping us, basically telling us this is how things should be, this is how things should look like, and this is what the real data is. And for example, in the solar system, you can go into the realistic view and get a sense of what the solar system actually looks like with everything at scale. And basically in this view, everything is really too small to be visible, but you can see that Pluto is really not on the same plane than everything else, and that the planets close to the sun until Mars are very, very close to the sun, but then as soon as you get to Jupiter and Saturn, everything is very far in between. And that's the kind of data we could patch.
That's really, because that's something that you would not learn otherwise looking at your flat picture on your screen.
Yeah.
Actually, yeah, go ahead.
A lot of textbooks will show like inner planets and outer planets as two separate things, as two separate diagrams, because the space in between and the sizes, like the size of the planet when you go into the realistic mode, you can't see anything. So we just draw the orbit lines, and like Kareem said, like they're so far apart. So in a textbook, you couldn't represent everything, so we sort of get away with it in 3D, and then you can zoom it up and fill your space with it, and maybe see a little bit of the sun, but it's pretty cool seeing that view.
So when you're doing things to scale, right? Is there problems that you sort of encounter? Because you mentioned that when you're playing in Unity, 1 meter is 1 meter.
Right.
So tell us about scaling.
So we cheated that a little bit. Basically, we moved the decimal point like 10 places so that we didn't have to worry about super precise stuff.
Nice.
But like Kareem mentioned, we had Dr. Dave Brown from MSR help us. And in his app, which is super like scientific simulation accurate, he actually had a ton of issues where once you get out to Jupiter and stuff like that, like your floating point doesn't have enough precision and your double starts running out of precision. So luckily we didn't have those problems because we're sort of, we scale it all in a little bit, but it's to scale, so the actual distances are real, but it's not 1 meter equals a meter, but it's scaled up relative. So.
Got it. All right. Next question. Will Galaxy Explorer be available in the Windows 10 store?
Yep, it's available now, so you can search for it, and you can get it on your HoloLens right now.
Awesome. Next question. When pinning a hologram, can you load up the last location it was pinned after the device has been powered off? How do you maintain state? For example, like there's this world that you maybe made. Is it something that is, can you save it and then when you put it on, you're like, oh, everything's back where I put it?
It's definitely doable. We actually did not do that for this app. So you can save state, similarly how you would do other applications. So if you know what state you're in, you can record that data, and then when you load the app the next time, you can load it in that state. So when we transition between the different locations, we actually don't save state. So we go back into that hero view just because it looks nice.
Yep.
And then we also have a reset button that resets the hero view. So if you want to play with the tilt and make the planets very large, then you can do that, and you can go back to the hero view manually.
Well, we are almost out of time. So get the last sort of 10 seconds each, call to action. Where can we go to find this? Where can we go to learn more about HoloLens development? I'll give you about 10 seconds each. Go ahead.
Yep, so if you go to github.com/Microsoft/Galaxy Explorer, you can find everything there, links to our YouTube series that we recorded, behind the scenes stuff, link to sweet blog posts about how we rendered the Galaxy, all that stuff. So go there, get started, download the tools, run it in Unity and the emulator, and have fun.
All right, 2-word tips that you have for HoloLens developers. I know, no pressure. Something short you can say.
Have fun.
Have fun.
Yeah.
stole it. But yeah, it's awesome. It's really easy to get lost into having a lot of fun, and this is just an incredible experience.
Awesome. Thanks so much for being with us. Thanks so much for watching. We're going to cut now to a session. Keep watching. Good stuff all day today. See you around.